Today we're going to be looking at how to solve one-step subtraction equations with negatives. We have a couple of examples that we're going to work through together here, so let's get started. For question number 1, we're being asked to solve for the value of r in the problem r minus 8 equals negative 2. And in order for us to isolate our variable of r in this problem, as we can see up top highlighted in yellow, we're going to need to perform the inverse or the opposite operation of whatever is being done to our variable in this problem. In question number 1, we're subtracting 8 from our variable of r, so in order for us to cancel out this subtraction, we're going to have to perform the inverse operation. And the inverse operation of subtraction is addition, so on the left-hand side of this problem, we're going to be adding 8 so that we can cancel out the subtracting 8 and isolate our variable. But this brings up a very important point here, which we can see up top highlighted in blue, which is that we need to keep both sides of this equal. So we need to make sure that since we're adding 8 to the left-hand side of this problem, we're going to do the same thing to the right-hand side of this problem as well. So on the right-hand side, we're going to be adding 8. So starting out with the left-hand side here, well, our subtracting 8 and our adding 8 cancel each other out. So now our variable of r is isolated. And then on the right-hand side here, we're going to be adding 8 onto negative 2. And when we add 8 onto negative 2, we're going to be increasing in value. So we're going to get the answer of 6. So r is equal to 6. And just to make sure that we got the correct answer here, we're going to plug in our value for r in our original problem just to make sure we have the correct answer. So we have 6 minus 8 equals negative 2. And when we subtract 8 from 6, we get negative 2. And then since both sides of this equation are equal, it means that we have the correct answer. R is equal to 6. Now moving on to question number 2, where this time we're being asked to solve for the value of n in the problem n minus negative 10 equals 35. So just like with our first problem, in order for us to isolate our variable of n, we're going to need to perform the inverse operation of whatever is being done to our variable. And here we're subtracting negative 10 from our variable, and the inverse operation of subtraction is addition. So on the left-hand side, we're also going to be adding negative 10, and then we need to make sure that we keep both sides equal. So on the right-hand side of this problem as well, we're also going to be adding by negative 10. Starting out with the left-hand side here, subtracting negative 10 and adding negative 10 cancel each other out. So now our variable of n is isolated. And then when we add negative 10 onto 35, we're going to be decreasing in value. So when we add negative 10 onto 35, we get 25. So n is equal to 25. And just to make sure that we got the correct answer here, we're going to plug in our value for n in our original problem. So we have 25 minus negative 10 equals 35. And remembering that whenever we're subtracting a negative, we're actually increasing in value. So when we subtract negative 10 from 25, we get 35. And then since both sides of this equation are equal, it means that we have the correct answer. N is equal to 25. And if you're unsure of why it is that when we subtract a negative, we increase in value, then I encourage you to pause this video and take a look at some of the video links in the description below, where we go over adding and subtracting both positive and negative integers in a lot more detail. So hopefully by now you understand how to solve one-step subtraction equations with negatives. Help make math less complicated by smashing those like and subscribe buttons. As always, enjoy today's math journey.